quantitative material requirements specify 4 missions for helicopter armament: fire suppression, anti-tank, air-to-air, and an area fire or soft capability. This Phase 1 program was to develop a satisfactory means of launching standard off-the-shelf 2.75 rockets from the UH-1B helicopter. Testing was conducted in 3 separate segments. Ground firings, with the helicopter firmly locked in place. Hover final segment, rockets were fired at varying forward flight speeds. The problem was to design a launcher that would provide a means of firing these weapons from the helicopter. The universal pilot. The investigation revealed that the 2.75-inch folding fin rocket was the best choice based on performance, aerodynamics, accuracy, and potential improvement capabilities. The weapon has a total length of 48 inches and a total weight of 17.8 pounds. The warhead weighs 6.5 pounds and contains 1.25 pounds of high explosives. Preliminary investigations began with an auto-rotational landing program. These landings were made to determine that the armament system was structurally capable of standing any maneuver within the operational envelope of the helicopter. These tests were completed with no problems resulting. Many of the firing sequences used in this film were photographed in slow motion. The initial ground firing tests were made with the aircraft tied down in a fixed position. These were used to measure stress levels in the support structure. Recorded data taken during the firings was evaluated and found acceptable. Single pairs were fired from each of 24 tubes for verification of stress levels, firing circuits, and firing order. Recorded data taken during this testing reveals that all results were acceptable. During the second segment of this test program, the system was fired from the helicopter in a low hover position. In this portion of the investigation, instrumentation was used to record ship response, including G-forces resulting from launching, controllability of the craft, the natural frequency of the launching system, amplitudes of oscillatory loads, and the corresponding stress level. The launcher system was designed so that the rockets can be fired in pairs, in short ripples, or the entire complement of 48 rounds can be fired in one ripple of 4 seconds duration. During the hover firing demonstration, the ripples were increased from the single pair firings of the ground investigations to a full load of 24 pairs, including a full 24-round ripple on one side only to investigate ship response. The fire control system contains a computer that will calculate the launcher elevation required to hit the target area in relation to the ship's speed, altitude, and other variables. The firing circuit contains an interbolometer with controls for selecting the number of pairs, each independent of the other. They can also be fired in a split mode of operation. In this mode, the co-pilot triggers the weapon on a line-of-sight control unit while the pilot controls the ship. In all cases, the launcher and firing system operated satisfactorily and proved compatible with the aircraft during the hover investigations. The final flight firing segment of the program was devoted to testing the launcher under simulated tactical launch conditions. Speeds ranged from single pairs through intermediate ripples of multiple fire systems. The Results of this Phase 1 flight firing investigation demonstrated that the launcher and its fire control system proved effective in providing the HU-1B helicopter with a highly acceptable area fire capability. The Phase 2 development program for this system will include improvements in pairs to maximum full load firings. The pattern of the impact was compact and appeared reasonable. The impact density was adequate for control components, rocket improvements, and warhead improvements.